Alright everyone, so today we are going to be doing 15.2 notes, which is adding and subtracting and multiplying matrices. So I know that this is going to be a video because I'm not here today, but I actually think it's a really good thing that it's a video because I think it's going to be a lot easier because everybody's going to want to see this at their own pace. You might want to pause the video to see where everything's coming from. So I actually think out of all the lessons, this is a really good one to have in the format of a video, and hopefully you'll see why. So some quick key vocabulary here. Matrix addition is commutative because A plus B is equal to B plus A, and is associative because A plus B grouped together, then plus C, is the same thing as A added to an already added B plus C. But matrix addition can only be completed on matrices that are the same size. That's super important, so make sure you're aware of that. So we have two matrices here, A and A plus B, which results us in a third matrices, A plus B. So you can see here we're basically just adding those elements. So A 1 1 plus B 1 1. That's what we get as a result here. Okay. Same thing for the next one. 2 plus 0 is 2. We got 3 plus 11 is 14. So that's the result of how we get each of those new entries. Now, what we're going to do is we're going to use A and B and find A minus B plus B. So we're going to use the same idea to do so. So A minus B is going to be equal to, so A minus B, so 7 minus negative 1. And then we have 2 minus 0. And then we have negative 1 minus 6. And then we have 3 minus negative 12. Negative 10 minus 10. 12 minus 2. 15 minus negative 9. Oops. 3 minus 11. Negative 8 minus 7. So then we do that calculation and we get 8, 15, 24, 2, negative 20, negative 8, negative 7, 10, and negative 1. So that's how you do matrix addition and subtraction. So the next one says, given C and D, what is C plus D? Now right off the bat, I noticed that this is a 2 by 2 matrix, and this is a 2 by 3 matrix. Remember, it's row, then column. So I can't add C and D together because they're not the same size. It only works when they are the same size. So example 3 says Marcus is saving money to buy a car. He has 2 after-school jobs to earn money to put towards buying his dream car. The given matrices represent how much Marcus earns during a 2-week period from tutoring and mowing lawns. So as we can see, week 1 and week 2, and it's by day of the week. So it's how much money did Marcus earn each day of the week for each job in total during this 2-week period. So when I read this, trying to dissect what it's saying here. Earn each day, so we want to keep it categorized by Monday, Tuesday, Wednesday, so on, of the week for each job. So we want to keep the jobs separated, so tutoring and mowing, keep those separate. And then in total during the 2-week period, so we're going to be adding together the Mondays together that are tutoring. Then we're going to add the Mondays that are mowing. And we're going to create a matrix that represents both weeks. But we're still keeping everything separate. So Monday, Tuesday, Wednesday, Thursday, and Friday. And then we have tutoring and mowing. So in total on Mondays, he makes $65 tutoring. Mowing, he makes, $33. Tuesdays tutoring, he makes 65. Tuesdays mowing, he makes 41. Wednesdays tutoring, he makes 48. Wednesdays mowing, he makes 40. 57. 42. 70. And 40. Then the next one says, how much more or less money did Marcus earn week 2 for each day of the week of the job? So basically what we're going to be doing is we're going to figure out how much more he earned in week 2. Now that means that if there's an amount of any type in week 2 that's less than week 1, we're going to have a negative number, and that's okay. So we have Monday, Tuesday, Wednesday, Thursday, and Friday. We have tutoring and mowing. So comparing Monday tutoring, he makes $5 more in week 2. To compare Monday mowing, he makes $3 more. Compared to Tuesday, he actually makes less in week 2. So he actually basically goes down $15, right? For mowing, he makes an extra $1. On Wednesday, for tutoring, he makes an extra $8. On Wednesday, for mowing, he makes $4 more. Tutoring makes $7 more on Thursday. Mowing on Thursday, he actually goes down $2. Tutoring, he makes $6 more. And then lastly, he goes down $10 for mowing on Fridays. So now we're going to kind of change gears here and talk about multiplying matrices. So the first thing we're going to talk about is scalar multiplication. So this is where you multiply each entry in the matrix by the scalar. Scalar is like just a number that we're multiplying something by. So if you multiply a matrices by a single number, you're essentially just multiplying each entry in the matrix by that number. Okay? So it's pretty straightforward. Now where it gets more complex is where we multiply two matrices together. So in order to multiply two matrices together, their outer values have to match. They must be the same. Okay, the outer dimensions. So for example, if I have matrix A being a 2 by 3, okay, 2 rows, 3 columns, and I have matrix B being a 3 by 4, I can multiply these together because the number of columns in the first matrix is the same to the number of rows in the second, okay? So if we look at this one, notice that the columns and then the rows match, and the resulting matrix will have rows, columns that are basically the outer portions of the original. Okay, that's where the 2 and the 4 came from. So we'll get more into that in a bit, but here's how you actually do the multiplication. This is like a little example of it, but I think it's just going to be easier for me to actually show you the process when we get there. So I'll kind of come back to it when we get to that point. But the next question is just what we would call scalar multiplication, because we're just multiplying each of these matrices by a regular number out front. So let's go ahead and do that first. So before we can add these two together, we're going to have to do scalar multiplication on them. So I'm going to find 3a, and that just means I'm going to multiply every element in the matrix by 3. So we got 21, we got 9, 45, 6, negative 30, 9, negative 3, positive 36, and negative 24. And then we have 2b, which is negative 2, negative 24, negative 18, 0, 20, 22, 12, 4, and negative 14. Then we are going to add these two matrices together. So just like we did above, we're going to add each of those corresponding entries together. So that's going to be the first thing we do. So that is 19. And then just a reminder, this is the next one we're going to do below it. 9 minus 24, negative 15. I'm going to have to use a calculator, so let me turn on the light. Okay. And then we have 45 minus 18, 27. And we have 6 minus 0. I just realized I'm supposed to be adding these. Oh yeah, I have been adding them. It's just these happen to be negative, so I guess I've been doing it correctly. Yeah, 6 plus 0 is 6. Negative 30 plus 20 is negative 10. 9 plus 22 is 31. Negative 3 plus 12 is 9. 36 plus 4 is 40. And negative 24 plus negative 14 is negative 38. So this would be the answer to our question. That is this right here. All right, that's page 1. Let's move on to page 2. Okay. So now we're going to do some actual matrix multiplication. We're going to be multiplying two matrices together. So the first thing I do is I just make sure that this is possible. So this is a 2 by 3, right? Rows, columns, and this is a 3 by 2. So if the second number of the first and the first number of the second match, that means that you can multiply them together. And the resulting matrices is going to be a 3 by 3. Or no, I'm sorry, it's a 2 by 2. It's going to be, the resulting is going to be the outer portions, okay? But the inner ones have to match in order to be able to do it. So I would say going into this process, it's more tedious than it is difficult, and it's easy to make a simple mistake. So that's why we're going to take our time, just go slow. I'm going to write it really big so we have lots of room here. And we're going to do the multiplication, and then once I get it, I can simplify it down and condense it. So I'm going to go through each step. I'm going to try to color code it as much as I can here to make sure you understand. So just bear with me time-wise because I want to make sure I'm color coding everything. So you're going to take the first row of the first matrix. You're going to multiply it by the first column of the second one, okay? Each one of these entries are going to get multiplied together and then added. And that's going to be the very first element right here, okay, when we do that. So that's going to be negative 1 times 5 plus 2 times negative 4 plus 3 times 2. You see where all of those came from. So I'll just color code this one so that you see where everything came from. I'm not going to do this for each one or we'll be here all night and day for you guys, but that's where I got those from, okay? Now what we're going to do in green, we're now going to take the second row of the first matrix and multiply it by the first row again. And we're going to go down and write it right here, okay? So that's going to be 4 times 5 plus 0 times negative 4 plus 5 times 2. So what you might be noticing is, see, these numbers here match, and then these are the ones that are changing because that's changing rows, okay? Now we're going to move on to the next one. Now, we know this is going to be a 2 by 2, so I probably gave a little bit too much room than needed, but, you know, it's better to have too much than not enough. So now we're going to move on to the next section of this thing, okay? So see how we're done with working with this first column of the second matrices? Now we're going to move on to the next one. And I'm going to color code it for you guys once again. So we're going to work here, okay? We're going to do this first row times the second column. So same idea. -1 times -1 plus 2 times 0 plus 3 times 3. And then second row, second column. 4 times -1 plus 0 times 0 plus 5 times 3. And once again, what I was talking about, you're going to notice these numbers are going to match just like these numbers match, okay? So the hardest part is just remembering what the steps are. So you're always going to go across, down, across, down, across, down, across, down, okay? The color coding, I think, helps a lot. I thought I was stuck. And then all you're going to do is actually just simplify this down, because it's just a 2 by 2, by doing the calculations. So here I have -5 plus -8, which is -13. -13 plus 6 is -7. Here I have 20 plus 0 is 20. 20 plus 10 is 30. Here I have 1 plus 0 is 1. 1 plus 9 is 10. -4 plus 0 is -4. -4 plus 15 is 11. So this is equal to CD. Not to be confused with DC, because CD and DC are two different things, because with matrix multiplication, order does matter. It's not like regular number multiplication. And we'll see an example of that for the next question. Look at that. How convenient. Okay, next question. I guess I won't erase that. You know what I'll do? I'll just write it again down here. So I have C and D. You know, it actually would make sense to write D first now because we're multiplying D times C. All right, we're here. Now we're going to multiply D and C together. So this matrix is a 3 by 2, and this is a 2 by 3. So remember, the numbers on the inside, okay, we're looking at those to match. The outer numbers are going to give you the result of the matrix. So the resulting matrix is going to be a 3 by 3. I don't know why that pen is like a crayon. I think I picked the wrong one. Okay, so let's do the math here. I'm going to make a really big matrix because we're doing a 3 by 3 here. We gotta have room for that. That looks uneven. Okay, So same kind of procedure. We're going to go across and down. Okay, that's our first element. So that's 5 times -1 plus -1 times 4. Gonna do that again. But now we're going on to the second row, still times the first column. So we have -4 times 4 plus 0 times 4. We have 2 times -1 plus 3 times 4. Now I'm thinking we're probably going to need a little bit more room, so I'm just going to kind of leave it open-ended for now. Now we're going to move on to the next column of our matrices. So I'm going to have to get really creative with the color choices here. So next one, remember you start again with the first row. Now you're on to the second column. So that's 5 times 2 plus -1 times 0. Now we're moving on again onto the second row, second column. I don't know. Running out of ideas. Then we have this one here times this one. Now we're going to move on to the last one. This and this. Okay, I think we're done. So what you're going to notice is, I think I wrote it like backwards here, but it doesn't matter. These numbers are matching. They should be. Let's make sure I did the red one right. Yeah, I made a mistake here, so that's how it's easy to catch. So what you're going to notice is these numbers are going to match if you do it correctly. See? This one I'm just not sure if I wrote it backwards, so let's take a look at that purpley one. Changing the wrong pen. This pen thing is getting a little confusing, I'm not going to lie. Okay, so we have 4 times 3, -4 times 3, and then we have 0 times 5. Yeah, I just wrote these in backwards, which just makes it look unnecessarily confusing, so we're going to just switch it around because this is tricky enough as it is. So once again, like I was saying, these numbers match, okay? So that's kind of what helps you visualize what's happening here. And then on the across, this number and this number and this number match. This one and this one and this one match, and so on, okay? So that's going to help you kind of keep track to make sure that you're doing it correctly. Now that we have all that written out, we're going to go ahead and do the calculation. So this is going to be -5 plus -4, which is -9. Then we have, right here, I'm just going down. We have 4 plus 0, which is 4. We have negative 2 plus 12 would be 10. And then we have 10 plus 0 is 10. And then we have negative 8. And then we have 4 plus 0 is 4. And 15 minus 5 is 10. And negative 12 plus 0, of course, nothing changes. And then we have 6 plus 15, which is 9. So this is DC. And now we just want to find 2DC. So the good news is we already know what DC is. So this is just a scalar multiple. Property, I don't know what I'm talking about right now. Multiple. I apologize. Sometimes doing math from 6 a.m. to 10 p.m. does not always pan out so well. All right, so we're multiplying each element here, each element in this matrices by 2. And this is equal to 2DC. So you can see scalar multiplication is a lot easier. I know you're all capable of doing this math here, okay, in here. It's simple when you actually think about it. It's just you have to get the process down, okay? So feel free to rewatch it if needed. Go back, scroll back. Now, as for the key for the homework, you might be wondering. Here's the information about that. So when you go to modules, you're going to go to modules, you're going to go to 15.2, where you're going to submit your work like you always do, okay? There's going to be 2 links. It's going to say notes, and it's going to say assignments. I think I spelled that wrong, okay? Usually the notes is linked there, the assignments are linked there. Cool. Okay, so if you click on the little S for assignments, I'm going to link the key under the S, okay? So you just click on the S, and it's going to pop up with a key. And the reason I'm saying this is because I want to make sure you guys watch the video before you get the key. So don't tell your friends if they didn't watch the video. They can find it for themselves. But yeah, so that's it. We'll have review tomorrow, Thursday. So you can feel free to ask me questions then. You have Delta Math to help prepare you. And then we have a quiz on Friday. So good luck everyone tomorrow, and I'll see you on Thursday.